So now let's understand what permutation and combinations are. So first of all, before we get into this, just a few points about factorial that you must remember. uh, N factorial, you all remember it is n into n minus 1 into n minus 2, and this goes up till 1, right? So what would be 1 factorial? 1 factorial would simply be 1. And what would 0 factorial become? 0 factorial would also be 1. Now there is a very long proof of this which you do not need to remember, so you can just remember this thing: 0 factorial is equals to 1. Now let's get into our permutation and combinations. So first of all, what is permutations? When do we use this formula of permutation? When we have to, let's say, select and we have to arrange as well. When we have to select certain number of objects from x number of given objects, and then we have to arrange those selected objects as well, that time we use this formula of permutation. For combinations, when we have to select distinct objects from, let's say, any category. So this is for selecting distinct objects. That time we use this formula of combination. Now generally permutations is a formula that we are not going to use much. We are mostly going to use NCR only for combination. Now I will show you a way when we have to select and arrange, that time how you can use a combinations formula for that. Now for permutations, this is our formula. Now the only difference that you can see in these two formulas is that in NCR there is a R factorial as well multiplied in the denominator. So that means NPR. What can I say about NPR? My NPR is NCR into R factorial. So remember this thing as well. Now again, as I mentioned, we are not going to be using NPR much while solving questions. We are going to solve our questions using NCR only. And whenever we have select and arrange questions, that time we are going to use this formula of combination to find out our total number of possibilities. Now a few more important things. NCR, of course, this is a thing you have seen in binomial theorem as well. I hope you all remember. We can represent NCR in this format as well. N, R, and then there's a bracket. So remember this thing, because generally in questions they might give you a combination either in this format or this format. So you must understand that they are trying to say NCR only. Now in this entire case, what can we say about R? Our R should always be less than equal to N, because R cannot be greater than N, right? Like if we have NC N plus 1, it is not possible. It is always has to be less than N or equal to N. So it can be NCN or any other value, and R would always be greater than equal to 0. So remember this thing as well. And a few more, just a revision from the binomial theorem. NC0, I hope you all remember, it's 1, and this is also equal to NCN. So what can we say about NCR? This is equals to NC N minus R. Again, a binomial theorem formula we are studying here. These are going to be useful for you while solving questions as well. So keep these things in mind. Now let's look at a few examples. For permutations example, how many ways? Again, for permutation, as I said, we have to select and arrange. So in this question, what have they given us? How many ways can 3 books be arranged on a shelf from a collection of 5 books? That means, first of all, I have 5 books. Out of these five books, I have to select any 3 books, and then I have to arrange those 3 books on this shelf. So basically I'm going to use my permutations formula, which is going to be 5p3, right? And simply if I substitute values in my 5p3, I would get my number of combinations. Now how could I solve this using a combination formula? As I said, we are not going to be using permutations much. We are going to be solving using our combination formula only. Now first of all, I have 5 books. So I have book 1, book 2, book 3, book 4, and book 5. Now Now, as we had seen here, what is combination? Combination means when we are selecting distinct objects. So here I have 5 books. Out of these 5 books, I have to choose 3. That means I can use my combination formula from 5 books. I have to choose 3. So it becomes 5C3. Now I have to arrange these 3 books in different ways, right? So I have, let's say I chose, for example, I'm saying I chose book 2, book 4 and book 5. Now in the shelf there are 3 spaces in which I can arrange these 3 books, as we had seen in the first example as well. Now let me choose book 1 first. If I choose book 1, how many ways can I arrange this book? It can either go here, here or here. So there are 3 ways. Then I would be left with just 2 spaces. Now book 4 can be arranged in either of these 2 spaces. So it would become 2, and for book 5 it would become 1. So this is basically 3 factorial. Arranging 3 books in 3 spaces would become 3 factorial. So this would become into 3 factorial. So now if you look at this formula carefully, this is nothing but my permutations formula. Because 5C3, how are you going to write it down? It would become 5 factorial upon 3 factorial into 2 factorial. 5 minus 3, 2 factorial. And I multiply it by 3 factorial as well. So 3 factorial and 3 factorial would cancel out each other. So I would be left with again this formula only. So this is the way that we are going to use to solve our questions, mainly combination one and not the permutation one. Now let's look at a combination example. Now this is fairly easy for you. How many ways can 2 students be selected from a group of 4 students? Simply 4C2. Now I hope you all remember from binomial theorem we had studied. Now every time you do not have to use this entire formula to find out your combination. What you can do is NC, let's say if I have 4C2, I can also write it down as 4 into 3, 2 times upon 2. Let's say if I have 7C3, how can I write it down? It can be written as 7 into 6 into 5. I've opened it 3 times and I divided by 3 factorial. So this was again a formula that we studied in binomial theorem. So keep these things in mind so that you can calculate faster the questions of P&C. Now let's look at this question. This was one of the questions that was asked in a previous year JEE Mains. If 2nC3 is to nC3 is to 10 is to 1, then the ratio of this is. So basically we have to find out the value of n given this ratio. So what is 2nC3? How can we actually, here there is a proportional sign and not a ratio sign. So basically they are saying that 2nC3 upon nC3, this is equal to 10 by 1. So the ratio is basically same since they are in proportion. Now let us simply open this up. 2nC3, how can we open this up? Either you can use that formula that we had studied, 2n factorial upon 2n minus 3 factorial into 3 factorial. Or simply, since there are only 3 ways in which you can open this up, so you can write it down as 2n into 2n minus 1 into 2n minus 2 upon 3 factorial, 3 into 2. And below what do we have? N into n minus 1 into n minus 2 upon 3 factorial again. This value is equals to 10 by 1. So from here 3 factorial cancels it out. N and n gets cancelled out. N minus 1 would cancel this term out twice because n minus 1 into 2 would give us 2n minus 2. So now what are we left with? 2 into 2, 4. 4 2s are, now let us simply multiply. This would become 4 2s are 8n minus 4. And here we are going to have, we have cross multiplied as well. So this would become 10n minus 20. Now let us solve this. This would make it 16. So from here we get our n is equals to 8. So this is the value of n that we've gotten. Now let us simply find out this value. We have to find out n square plus 3n divided by n square minus 3n plus 8 in this equation. What are we going to get? N square, 8 square becomes 64 plus 8 3s are 24 divided by n square 64 minus 24 plus 4. So from here what do we get ultimately? This would become 88 divided by here we are going to have, this would become 44. This cancels this out twice. So this becomes our answer. Again, a fairly easy a fairly easy question. The only thing that you had to do was substitute using the combination formula and find out your answer. Let's look at next question. There are now this is a very good question, and based on this question all your doubts on combinations would be cleared out. Now there are 3 sections in a question paper. So first let us write it down. Let's say my first section is A, my second section is B, my third section is C. And each section has 5 questions. So remember this thing, each section has 5 questions. That means I have 5 different questions in each and every section. A candidate has to answer total of 5 questions. So ultimately, first of all, I have 15 questions, out of which I have to choose only 5 questions. Now he has to choose at least one question from each section. That means one question should come from each section, and rest he can choose from any of the sections. It can be 2 from A, 2 from B, or 2 from C, or it can be 3 from A, 3 from B, anything. Then the number of ways in which the candidate can choose questions are. So firstly, what we are going to do, since he has to choose one question from each and every section, that means I have to choose one question from each and every section. I'll put 1 here. Now still there are 2 questions left that I can choose more, right? I have to choose ultimately 5 questions. Now I've distributed 3 questions in each and every section. I have to choose 2 more. What I can do is I can either choose both the questions from the same section, or I can choose 1 and 1 from different sections, right? So let's say if I choose both the questions from A section, so this would become 3. Now this thing can be applied to other sections as well. I can either choose 3 questions from B and 1 from A and C, or I can choose 3 from C and 1 from B and A. This was the first way. Now what are the other ways? Other ways is that I choose 2 questions from one section, 2 from another, and 1 from one of them. So let's say if I choose 2, 2 and 1, this can be one of the ways. Now I can arrange this as well. So this would become 1, 2, 2, and this can also be 2, 1, 2. So now what are the number of ways so in which this combination can be done? This can be done as I'm choosing 3 questions from section A. Section A in total had 5 questions, right? So out of those 5, I'm choosing 3. Now from B had 5 questions and I'm choosing 1. Since AND is being used here, that is why I'm multiplying all these combinations. Here from C as well, this is what my total combinations can be. I hope you are understanding this thing. We could have chosen 5 questions in 2 different ways. Either 3 questions from one section or 2 questions from 2 different sections. And of course, we have to choose 1 from each and every section. So that is how our 5 questions get divided. Now we are finding out the number of combinations for each and every way. Now let's say if this was the case, I had to choose 5 from 5 questions of A, I had to choose 1 question, and from 5 questions of B, I had to choose 3 questions. And in C also had 5 questions, so 5C1. I hope you are understanding this portion here. Now for the third one as well, it would be written in the same format. Now you can see that all these 3 are more or less same. So ultimately, what can I write this down as? Since these are combinations, so this can be either this or this. Either this is the combination that I'm choosing, or this is the combination, or this is the combination. That means I will have to add all these combinations. So if I add all these combinations, what would it become? It can be written as 5C1 into 5C1 into 5C3 into 3. Since all these 3 are same only, so I can directly write it down in that format. Now let's look at this way. Here also, again, I will be using the same concepts. I have 5 questions in A and I have to choose only 2. So I can write it down as 5C2 into same way 5C2 into 5C1. Same thing goes for here as well. 5C1 into 5C2 into 5C2. Here also 5C2 into 5C1 into 5C2. Now you can see that all these 3 are same again. So I can write it down as 5C1 into 5C2 into 5C2 into 3. Since these are either or combinations, right? Now this section and this section is also in OR combinations, right? So I have to add these two combinations and that would give me my answer. So let us simply add these two combinations. What do we have in the first combination? I have 5c1, which can be written as 5 into 5 into 5c3. So 5 into 4 into 3 divided by 3 into 2 into 3, added with my second section, which is 5 into 5c2 into 5c2 into 3. So from here, what are we going to get? This 2 and 2 would cancel out, 1 4. This 3 would cancel out this 3, 2 would cancel out this 2. From here, what we can see is we can take 125 common. We would be left with 3 2s are 6 plus, and here we would have 4 3s are 12. So 18 would be left here. So 125 into 18. So, and this calculation gives us 2250 as our answer. So this is how combination questions are done. So remember this thing, you will have to build cases during questions, and this was also a question that was asked in one of the previous JEE Mains papers. So remember this thing. I'll repeat, I'll give you a summary of what we did exactly in this question. There were 3 sections given to us in the question paper, out of which we had to select, in each section there were 5 questions. So in total, I mean, we had 15 questions. Out of those 15 questions, we had to select basically 5 questions. Now they had given us a condition that out of these 5 questions, 1 question should be from each and every section. So if I have 3 sections, let's say A, B, C, and if I give each section 1 question, how many questions are still left for me to choose? There are 2 questions more left. So what are the ways in which those 2 questions can be selected? Either those 2 questions get selected from the same section, which we did 3 3 3, or those 2 questions can be chosen from either of any 2 sections, right? So that is what exactly we did, and then we found out our number of combinations. We got our answer. Let's look at one more example. A scientific committee is to be formed from 6 Indians and 8 foreigners, such that it includes at least 2 Indians and double the number of foreigners as Indians. So first of all, we know that we have 6 Indians and 8 foreigners, and whatever group we form or whatever committee we form, in that committee, the number of foreigners should be double the number of Indians. So first of all, let's say if I have Indians here and I have foreigners here. So what are the cases that can be formed in this question? Let's say at least, it has also told us that it should include at least 2 Indians. That means having 1 Indian is not a possibility. That means we will have 2 or more Indians, right? So let's say if I have 2 Indians, how many foreigners would I have to choose then? I would have to choose 4 foreigners, because the number of foreigners is double the number of Indians, right? If I have 3 Indians, this would become 6. And if I have 4 Indians, this would become 8. And now if I have 5 Indians, I would have to choose 10 foreigners. However, I have only 8 foreigners. That means this case is not possible, right? I have a number of Indians more, but I cannot choose them because I do not have sufficient number of foreigners to counter that part, right? That is why there are only these 3 cases possible. Now it is very easy for us to solve. There are 6 Indians in total, 8 foreigners in total. Now let us look at this case. I have to choose 2 Indians from 6. So 6c2 multiplied by, I have to choose 4 foreigners out of 8 foreigners. So it will become 8c4. Now let us look at this case. I have to choose 3 Indians from 6. 6c3. 8 c6. Similarly for this one, it would become 6c4 into 8c8. Now since these were the cases that were possible, that means either this or this or this. So again, I would have to add all these up. Now let's simply just add these sections. What do we get our answer? Upon adding, we would have 6 into 5 by 2 into 8 into 7 into 6 into 5 by 4 into 3 into 2 plus 6 into 5 into 4 divided by 3 into 2 into 8 into 7 by 2. Again 8c6. I hope you all remember 8c6 can be written as 8c2. That is why I did just 8c2. plus 6c4. 6c4 can be written as 6c2. So this would become 6 into 5 by 2 into 8c8 is nothing but 1. Now let us simply add all of this up. We are going to get 1625 as our answer. So I hope you must have understood based on these two examples, this one and this one, how you can choose from a set of people and satisfy the conditions that have been given in the question. Let's look at one more example. The number of 4-letter words with or without meaning, each consisting of 2 vowels and 2 consonants, which can be formed from the letters of the word universe without repetition. So first of all, let us segregate our vowels and consonants from the word universe. Universe has how many vowels? What are our vowels? A, E, I, O, U. So 1, 2, 3 and 4. That means U, I, E, E. These are our vowels. And what are our consonants? N, V, R, S. So there are 4 consonants and 3 vowels. These are 3, sorry. And I have 4 consonants. Because E is same here, that is why it becomes 3. So I can only write it down as E. Now, again, there was a point in the question where they mentioned that which can be formed from the letters of the word without repetition. That means the same letter is not getting repeated again and again. That is why we can remove E from here, one E from here. So now we have to form a 4-letter word. And they've told us, again, with or without meaning, it should have 2 vowels. It should have 2 vowels. This is my vowel and this is my consonant. It should have 2 vowel and 2 consonants. So that means from vowel I will have to choose 2, from consonant I will have to choose 2, and then I can arrange those in 4 different ways, right? Because all those 4 words are going to be different. So from my vowels, how can I choose 2 letters? It would become 3C2. Out of 3 I'm choosing any 2. From here I have 4 consonants, I have to choose 2, so it would become 4C2. Now since I have to choose 2 vowels and 2 consonants, so this would be in multiplication format, and now I have gotten my 4 letters. Now I can arrange these 4 letters in these 4 spaces in 4 factorial ways. So this would become 4 factorial as well. So what does my answer become? 3C2. 3C2 is 3 into 4C2 is 6 into 4 factorial. So my answer ultimately becomes 432. So this is how you solve questions. I hope you must have understood this. We chose 2 vowels from this set of 3. We chose 2 consonants from the set of 4. And then now we have 4 letters with us. Now we can arrange these 4 letters in 4 spaces in 4 factorial ways, right? So that is how we get our answer.